Hi everyone! Today we're continuing Chapter 2. We're going to start by writing conversion factors, and then we're going to use conversion factors to solve some problems. So down below you can see a picture of some tuna, and the maximum amount of mercury allowed in tuna is 0.5 ppm or parts per million. So this is a unit that you might not see very often. I do see parts per million in, for instance, water quality data. So they'll tell you how many parts per million you have of fluoride or other chemicals in your water. But maybe we want to convert parts per million to a different unit. How do we do that? So we're going to start by looking at equalities. So equalities use two different units to describe the same measured amount. So down below we have a few examples. For instance, 1 meter is equal to 1,000 millimeters, or 10 to the third millimeters. I keep wanting to say milliliters, but it's millimeters. Now, additionally, equalities are written for relationships between units of the metric system, US units, or a combination. So if we're going from metric to US units or vice versa. So for instance, the first example we just went over was between two metric units, the meter and the millimeter. Our second example is between two US units. A pound is equal to 16 ounces. And then the last example, we're converting from a US unit to a metric unit. So 2.2 pounds equals 1 kilogram. So the 2.2 pounds is a US unit, and 1 kilogram is a metric unit. Whereas up above we had metric and US to US unit. Okay, so any equality can be written as fractions, called conversion factors. So a pretty common conversion factor we might use in our day-to-day life is converting from minutes to hours or hours to minutes. So we know that there are 60 minutes in an hour. So our equality would be 60 minutes equals 1 hour. Now we can write that as a fraction or a conversion factor. So we could put 60 minutes in the numerator or the denominator. It just depends on what we're trying to convert to and the units we're trying to get rid of. So for instance, we could have 60 minutes in the numerator over 1 hour in the denominator, or we could put 1 hour in the numerator and 60 minutes in the denominator. Now another example, 1 meter is equal to 100 centimeters. We could do the same thing that we did before. We could write two different conversion factors. One where 100 centimeters is in the numerator and 1 meter is in the denominator. Or we could put 1 meter in the numerator and 100 centimeters in the denominator. So we have two different ways to express that equality. Now, what about significant figures? How do we take that into account with equalities? So you might remember that equalities are exact numbers. However, that's only true if we're converting between two metric units or between two US system units. So if we're converting, let's say, between 1 meter and 100 centimeters there, so meters and centimeters, that would be considered an exact number. So the sig figs would be infinite. Or if we're converting between two US units, So let's say 1 pound equals 16 ounces. Because we're converting between two US units, that's also considered exact. Okay, so these equalities are obtained by definition, and a definition is exact, and therefore the numbers in a definition are not used to determine significant figures. So let's say we're doing a calculation where we're converting between meters and centimeters. Since meters and centimeters have a defined relationship, we would not use those two numbers to determine how many sig figs are in our answer. However, this all changes if we're converting between metric and US units. So as an example, 1 pound is equal to, oops, I got that mixed up. I meant to say 1 kilogram. So 1 kilogram is equal to 2.2 pounds. So we have our metric unit on the left and the US unit on the right. So if we're converting between metric and US units, that means we have one number obtained by measurement, and we would count that toward the significant figures. So the US part of our definition, the 2.20 pounds, that will be measured. And so we would consider the number of sig figs there. So there are 3 sig figs. But the metric side is exactly 1. So this would be considered exact, and we would not use that value to determine how many sig figs are in our answer. And it wouldn't really make sense to have only 1 sig fig anyway, so, but typically, again, if you're converting between metric and US, one side will be exact and the other side will be measured. Now, of course, there is an exception because there's always exceptions to the rule. The equality 1 inch is equal to 2.54 centimeters is defined as an exact relationship. So that is the one instance where we convert between US units and the metric system, and we consider both numbers to be exact. So 2.54 is an exact number. Now, there is a handy table in your textbook that summarizes this information. So you can see we have the metric, the US, and then the metric to US conversion factors. So again, everything in the first column where we're converting between 2 metric units is considered exact. And then everything in the US column, those are definitions as well, so we consider all of those numbers exact. And again, exact numbers do not have a defined set of sig figs, so we don't include them in our consideration of sig figs. However, if we look at the metric to US conversions, other than our first one there, which is a defined quantity, so it is exact, all of the other conversions have a measured value. So for instance, 1 meter is equal to 39.4 inches. That 39.4 is measured. 1 kilometer is equal to 0.621 miles, so that 0.621 is measured. And we can keep going down the list. So that means we do want to take sig figs into account, and both of those examples have 3 sig figs. So we'll just write sig figs down below. Okay, so again, remember that we can write a conversion factor in two different ways. So we start with our equality where 1 meter is equal to 100 centimeters. And so we can write this where 100 centimeters is in the numerator or in the denominator. So we're just flipping the conversion factor. Now both are proper conversion factors. One is just the inverse of the other. Now, because we're converting between two metric units, the meter and the centimeter, 100 and 1 are both exact numbers. So they have infinite significant figures, so we just don't include them in our final determination of sig figs. Now, there's also other equalities that we might have to take into account for certain problems. For instance, let's say we're given a problem where a car was traveling at a speed of 85 kilometers per hour. Okay, so we can write that as an equality where 85 kilometers equals 1 hour. And then we could write that as two different conversion factors shown in this table here. And they're just inverse of each other. And then when we're considering which part of the equality is measured, the 85 kilometers is what is measured. The hour is exact. Sometimes it's pretty easy to figure out which side is exact and which side is measured, but sometimes it can get a little confusing too. Now, let's say we have a problem where we're told that the price of onions is $1.24 per pound. So we can write that as an equality as well. So $1.24 is equal to 1 pound. So the dollar amount is what is measured, and the 1 pound is exact. Now we can write this in two different ways. So we could write it as $1.24 in the numerator over 1 pound, or we could write the inverse of that. So in our first example of 85 kilometers per hour, because the 85 kilometers is measured, that means we have two sig figs. In our second example, $1.24 is measured, and that means we have 3 sig figs. So if we were doing some sort of calculation, we would want to make sure our final answer has the same number of sig figs as our measured values. Okay, now what about if we're given a percentage? So a percentage is written as a conversion factor by choosing a unit and expressing the numerical relationship of the parts of this unit to 100 parts of the whole. So for example, let's say a person has 18% body fat by mass. That means that we can pick whatever mass unit we want. So let's pick kilograms, and we can say that a person has 18 kilograms of body fat for every 100 kilograms of body mass. Or you could flip that to get the inverse of that relationship there. And those are shown in the table below. Okay, so in this instance, the 18 kilograms of body fat would be measured. So how many sig figs would we have? 2. And then 100 kilograms of body mass would be exact. So at the beginning of the lecture, we saw the example of the tuna and how much mercury it contains, and that was reported in parts per million. So to indicate very small ratios, we use parts per million and parts per billion. Now this can get a little tricky. Again, we don't often see these units in our class at least, but you might notice them on different reports that you get. For instance, I had to test my soil for arsenic and lead because there used to be a smelting plant in Tacoma, and it deposited arsenic and lead in the area. So when I got my report back, it reported the amounts of arsenic and lead in parts per million or parts per billion, depending on how much there actually was. So parts per million, the units for that, if we want to express it in actual, units we're familiar with, we can express that as milligrams per kilogram. And then parts per billion is micrograms per kilogram. But again, we're not going to use those very often, so don't worry too much about those units. Okay, so let's do a learning check. Let's write the equality and conversion factors for each of the following. So A, meters and centimeters, so we'll write the equality between meters and centimeters, and then we'll write the possible conversion factors. B, jewelry that contains 18% gold, so that's a percentage. And C, 1 gallon of gas is $3.40. So feel free to pause the video and try these on your own, and then we'll go over them together. Okay, so let's go over A. So in A, we're comparing meters and centimeters. So we just saw on a previous slide that 1 meter is equal to 100 centimeters. So we can write that in two ways. We could write this as 1 meter over 100 centimeters, or 100 centimeters over 1 meter. So those would be our two conversion factors. And then B, we're told that jewelry contains 18% gold. So we could say that maybe, I don't know, let's pick a mass. 18 kilograms of gold exist for every 100 kilograms of jewelry. Okay, so then we could write that as 18 kilograms of gold over 100 kilograms of jewelry, or 100 kilograms of jewelry for every 18 kilograms of gold. And then C, 1 gallon of gas is $3.40. So we can say 1 gallon equals $3.40. So we can write that in two ways. We could say that we could put 1 gallon in the numerator, or we could put $3.40 in the numerator. It just depends on the unit we want versus the unit we're trying to get rid of. So we'll go over some examples of that in a bit. All right, and then here are the solutions if you need them later. Okay, so now let's apply those conversion factors to actual problem solving. So the process of problem solving in chemistry often requires one or more conversion factors to change a given unit to the needed unit. So problem solving in chemistry requires identification of the given quantity units, determination of the units needed, and then identification of conversion factors that connect the given and needed units. So for example, let's say we're given a particular unit and we're told that we want to solve for a needed unit. So let's say we're given meters and we have to convert to centimeters. So what we need to do is find a conversion factor to multiply by our given unit. So that conversion factor will have our needed unit in the numerator, needed unit, and then our given unit will be in the denominator. So what happens here is we cancel the given unit because we have it in the numerator initially and then in the denominator of our conversion factor. And at the end, we get our needed unit. So let's go over a problem together, and then I'll give you a problem to work on your own, and then we'll go over that together as well. So example, if a person weighs 164 pounds, what is the body mass in kilograms? Okay, so this is where we can make a chart of given units, needed units, and then the connection between them. So we're given that we have 164 pounds, and we need kilograms. So we need to find a conversion factor that relates pounds to kilograms. And pounds is a part of the US system of units, and kilograms is a metric unit. So we'll need a US metric conversion factor. This will also play into our sig fig determination at the end, so just keep that in mind too. Okay, so our plan is to convert pounds to kilograms using our US metric conversion factor. Okay, so if we go and look up a conversion factor between kilograms and pounds, and your textbook does have that table we saw earlier of all those different conversion factors, we would find that 1 kilogram is equal to 2.20 pounds. Okay, so just like we did earlier, we could write this in two different ways. We could put 2.2 pounds in the numerator and 1 kilogram in the denominator, or we could put 1 kilogram in the numerator and 2.2 pounds in the denominator. So what was our needed unit? Because that needs to go in the numerator. So what was our needed unit, pounds or kilograms? Kilograms. Okay, so we want to use the version of the conversion factor on the right. So we want 1 kilogram in the numerator. Okay, so then we'll just set it up as shown below. We will write 164 pounds times 1 kilogram over 2.20 pounds is equal to whatever our answer is. So in this case, pounds will cancel because we have pounds in the numerator and the denominator. And then we're going to plug into our calculator 164 divided by 2.20, and our final unit will be kilograms. And so that ends up being equal to 74.5 kilograms. Now the other thing we want to take into account are sig figs. So the given value, 164, has 3 sig figs. And then if we look at our conversion factor up above, 1 kilogram is an exact amount, but 2.20 pounds is measured. And it has 3 sig figs. So remember that when we're multiplying two values or dividing two values, we want our answer to reflect the least number of sig figs. Now, luckily for us, in this problem, both of our measured values have 3 sig figs. So our final answer should also have 3 sig figs. Okay, so I'm going to have you solve a problem. So I want you to pause the video and figure out if a rattlesnake is 2.44 meters long, how many centimeters long is the snake? So try this on your own, and when you unpause the video, we'll go over it together. Okay, so let's solve this problem. So we're told that a rattlesnake is 2.44 meters long. So that's our given value. And then we're asked to determine how many centimeters long is the snake. So that's our needed value. So our plan is to use the conversion between meters and centimeters. So how many centimeters are in 1 meter? 100. So we saw that earlier. And remember, I have the flashcards for prefixes up on the Canvas website. So it's under Modules, Study Guides, if you want to go through and memorize those prefixes. Well, you should memorize them, but if you need further help memorizing them, those flashcards are useful. Okay, so let's set up our problem. So we have our given value, 2.44 meters, and we're going to multiply that by our conversion factor. So now we have to decide, is 1 meter going in the numerator, or is 100 centimeters going in the numerator? So remember, we want our needed units in the numerator. So what should go there? 100 centimeters. So centimeters is what we need. So we're going to put that part of the equality on the top. And then we want to get rid of meters. So we're going to put 1 meter in the denominator. Okay. So now let's make sure our units cancel. So meters and meters are in the numerator and denominator, so they cancel. So if we simplify this expression that we've written out, we have 2.44 times 100 over 1, so we'll just leave that as it is. And our final unit is centimeters. Okay, so we just plug that into our calculator. What is 2.44 times 100? And you might be able to do this in your head too. So 244 centimeters. Okay, so we went from a 2.44 meter measurement to 244 centimeters. And here are the solution slides if you would like to look these over on your own time. Now, one thing we didn't quite go over was sig figs. So if we look below here in step 4, the given value had 3 sig figs. Everything was a non-zero digit. And then remember, in our conversion factor, we're converting between metric and metric, so meters and centimeters. So that means this is a defined equality and both numbers are exact. So we're not going to consider those numbers in our determination of sig figs. So that means our final answer also has to have 3 sig figs, similar to our original value. All right, so sometimes we have to use 2 or more conversion factors in a problem. And this is where things get tricky. Okay, so in problem solving, 2 or more conversion factors are often needed to complete the change of units. So in setting up these problems, one factor follows the other. Each factor is arranged to cancel the preceding unit until the needed unit is obtained. All right, so let's say that we have a given unit of A, and we need unit C. So let's say that we look up some conversion factors and we find that 1A is equal to 1B, and then let's say 1B is equal to 2C. So then we would set this up. So we'd start with, okay, I have 1A, and I'm going to convert that to B, and then convert B to C. So I have 2 conversion factors here. So first, I want to convert to B, so I'll put that in the numerator, and I'll put A in the denominator. Okay, so that's my first step, and A will cancel, so I'm left with B. And now in the next step, I'm going to convert B to C. So I want to end up with C, so I'm going to put 2C in the numerator and 1B in the denominator. So B will cancel, and I'm left with C. All right, so if we multiply everything together, we have 1 times 1 times 2 in the numerator, and 1 times 1 in the denominator. And then our final unit is C. So overall, that gives us 2C. Now, you might have been able to figure that out on your own just looking at the conversions, but we're going to come across some problems where the conversions aren't so easy. So I just wanted to step you through what this is going to look like. But let's do a practice problem, and we'll do this one together. So let's say a doctor's order prescribed a dosage of 0.150 milligrams of Synthroid. So Synthroid is a medicine that helps with thyroid cancer, or just if your thyroids aren't acting the way they should, Synthroid can help. So if tablets contain 75 micrograms of Synthroid, so if tablets contain that, how many tablets are required to provide the prescribed medication? So I like to underline the information I'm given because it can help me kind of organize my thoughts when I'm working through a more complicated problem. So, okay, in this problem, we're told that we have a dosage of 0.150 milligrams of Synthroid. So that's our given. And we need the number of tablets that we need to take in order to get that dosage. Okay, so a couple of things are going on here. So we're told that our dosage is in milligrams, but each tablet contains 75 micrograms. So we probably want to do a conversion between these two metric units. So that will be our first step. We're going to do a metric conversion between milligrams and micrograms. And then we're going to want to convert from our dosage to how many tablets we need. So we'll do our clinical conversion next. So down below we have our plan. We have milligrams, which we're starting with, and then we'll use a metric conversion factor to get to micrograms. And then we'll use our clinical conversion factor of tablets and micrograms to get the number of tablets. Now, if this doesn't quite make sense to you yet, that's okay. We'll do a lot of practice with these types of problems, and hopefully it will become second nature as the quarter keeps going. Okay, so let's write out our two conversion factors. So our first conversion, remember, was a metric conversion. So we're going from milligrams to micrograms. So this one's a little tricky because we might not know right off the bat how many micrograms are in a milligram. So one way to figure that out is to say, okay, in 1 gram, I know that there are 1,000 micrograms, but also in 1 gram, there are 1 million micrograms. Oh, I meant milligrams on the first one. Just caught myself. So there are 1,000 milligrams, there we go, and then 1 million micrograms. Okay. So if we compare milligrams to micrograms, let's start canceling some zeros. So we'll cancel 1, 1, 1, 1, 1, 1. Okay, so it looks like for every 1 milligram, there's 1,000 micrograms. Now, if you have a different method of figuring out how many, micrograms are in a milligram, that's fine. This is just the way I do it. It's just one example of how to figure it out. Okay, so down below, we figured out that there's 1 milligram, or 1,000 micrograms for every 1 milligram. And of course, we can write that in two different ways, so two different conversion factors. We could put micrograms in the numerator or the denominator, depending on what we need. And then our other conversion factor, we were told that every 1 tablet contains 75 micrograms of our medication. So we can also write that in two different ways. We could either put 1 tablet in the numerator or in the denominator. Now, remember from our previous slide, in the first step, we want to end up with micrograms. And then in the second step, we want to end up with tablets. So when we're picking conversion factors, we want micrograms to be in the numerator, and we want tablets to be in the numerator. So we're going to use those two specific conversion factors. Okay, so when we're setting up this problem, we're going to start with our given value of 0.150 milligrams, and then we're multiplying that by our first conversion factor. So 1,000 micrograms over 1 milligram. And then we're going to multiply that by our second conversion factor, 1 tablet over 75 micrograms. So then milligrams will cancel and micrograms will cancel, and we're left with tablets as our final unit. So we can simplify all of this and write this as 0.150 times 1,000 times 1 in the numerator, and then divide that by 1 times 75. So obviously we can cancel out the ones because they're not going to make a difference. But our final unit is tablet. Now when I plug this type of problem into my calculator, I always put parentheses around the numerator and then around the denominator, just to make sure I get the right answer at the end. What we should end up with is 2 tablets. Okay, so this problem's a little tricky because when we think about sig figs, our given value has 3 sig figs. Remember that first 0 is a placeholder, and then the second 0 is after a non-zero digit and a decimal, so it is significant. Then in our first conversion factor, we're converting between 2 metric units, so those are both exact values. And then in our second conversion factor, we have 1 tablet, which is exact, but then 75 micrograms is measured, and it has 2 sig figs. So typically we would want 2 sig figs for our answer, but because we're dealing with tablets, we have to count the tablets. So we would need 2 tablets. So this is one of those cases where sig figs doesn't necessarily matter. So, you know, there's always exceptions. Okay. Now let's do one more problem. How many minutes are in 1.4 days? So I'm going to let you try this on your own, and then when you unpause the video, we'll go over it together. Okay, so let's figure out how many minutes are in 1.4 days. All right, so our given value is 1.4 days, and we need that amount in minutes. Okay, so our plan. Well, I know that there are 24 hours for every day. And then I also know that there are 60 minutes for every hour. Okay, so those are my 2 conversion factors that I need to use. So I'm going to start setting up my problem. And I have 2 conversion factors. So I'll just set up those conversions there. All right, so in my first conversion factor, I want to get rid of days. So I'm going to put 1 day in the denominator. And then I know that that's equal to 24 hours. So I'll put that in the numerator. And then in the next conversion factor, I want to get rid of hours. So I'll put 1 hour in the denominator. And I'll put 60 minutes in the numerator. Okay, so let me make sure all my units cancel, and I end up with what I want. So days and days will cancel, and then hour and hour will cancel. And I'm left with minutes. Perfect. Okay, so let's simplify what we wrote out. So in the numerator, we have 1.4 times 24 times 60. And in the denominator, we just have 1 times 1, which is 1. And then our final unit is minutes. Okay, so let's plug this into our calculator. Let's see, so 1.4 times 24 times 60. All right, so that's 2,016 minutes. But what about sig figs? Okay, so let's figure out the sig figs here. How many sig figs are in 1.4? 2. Now, in our first conversion factor, is that a defined equality, or do we have a measured value? So that's a defined equality. So we're going to say that we have exactly 24 hours for exactly 1 day. And then what about our second conversion factor? Is that exact or measured? It's exact. So we have exactly 60 minutes for every 1 hour. Okay, so that just means that we need 2 sig figs in our final answer. Okay, so we're going to limit our answer to those first 2 sig figs, but we also want to maintain the fact that we have 2,000 minutes, right? We don't want to just say we have 20 minutes. So there's a couple of different ways we could write this. We could just write this as 2,000 and put a couple more zeros in there. However, this doesn't have 2 sig figs in it, right? It would only have 1 because those 3 zeros are placeholders. Okay, so that doesn't work. All right, so maybe we should use scientific notation. So what we'll do is we'll write 2.0 times 10 to the, what would the exponent be? 3. So 10 to the third is 1,000, and we're multiplying that by 2 to give us 2,000 minutes. And we have 2 sig figs. Okay. And then here are the solution slides if you want to go over those later. And I think we'll stop there today. Hopefully this gave you a good idea of how to go through some of these problem-solving conversion factors. So this is referred to as dimensional analysis sometimes. So you might see that term on your worksheets or your homework. Now, I know some people use the train track method. So you might kind of set up like a train track where you put your given unit followed by your conversion factors. And that's okay too. Whichever way you've learned how to solve these problems is totally fine with me, as long as you show your work so that I know that you know how to solve them. Okay, so I will see you in the next video. In the next video, we're going to go over density, and then that will be the end of chapter 2.